Another Wednesday, another rock day, since I usually record on Wednesdays. So today I have just 10, since I didn't find any repeats this time like I did the last time. So there's just 10 this time. They're all unique rocks from one another, fortunately, because I feel like it can get confusing to see rocks that are supposedly the same type but are actually so different in appearance. That's just something you're going to come across when you're out and about in nature. But without further rambling, here we go for the first one. This is a really cool one. I know I say that about a lot of my rocks, but that's because a lot of my rocks are really cool. I don't know what else to say about that. Anyway, so this guy's got little rings around the top. As you can see, it's more obvious around the top anyway. But it also has banding throughout the entire rock. This is actually a hint that this is a metamorphic rock. Because what happens with metamorphism, I guess I do have to get into some kind of detail as I go on through these videos, but maybe it'll avoid me having to make a whole other video on it, unless that's what you guys want. So when it comes to metamorphism, the more, like, the higher the pressure and the heat, the more metamorphosed the rock gets. So you see different, like, grades of metamorphism. And the highest grade of metamorphism will show you distinct color bands, like, as you see here, where you just see different mineral compositions, like, aligned and ordered in a neat way. Kind of like nature just started sorting the grains and then squashed them all together on top of each other in layers. You know, like those nice little pastries where you see different layers of different, like, types of filling and stuff like that. That's basically what these rocks get to once they're the highest grade of metamorphism. The first grade of metamorphism is basically just slate. It's a little shinier, but other than that, it might be harder to tell apart from, like, sedimentary rocks. And as the metamorphism increases, you start seeing shinier rocks and more foliation, which is just, you know, the alignment of minerals that cause the color banding at the very end of metamorphism. Schist is a really cool rock it looks extremely shiny, and that's because of all the micas in them. And phyllite is pretty much like one of the middle grades. I can't remember exactly if that's like the second or the third. I'll have to look it up. Yeah, it's been 2 years since I got my degree, and it shows. So, anyways, this guy, I went through the full gamut, I should say, of, like, IDing a rock. It really reminded me of back in the days when I was in university, and you would have to, like, note, does not react to acid. It's scratched by it's scratched by a knife, like, and that'll help you ID it as you keep, like, it's sort of like you keep a checklist of things that you have to cross off before you can know what a rock is. Like, there was a really cool, neat ID, like, rock ID chart that one of the professors made in my university, and I'm hoping to get access to it, fingers crossed. I do have to email him because I lost track of my old one. Again, don't get rid of things just because you think you're done with that past. You never know when you might need it. So, yeah. I unfortunately have a problem where once I think I'm done with something, I just tend to get rid of it, and then I usually end up regretting it. Anyway, so I'm gonna start that little, not start the whole thing, but I'm just gonna go off of what I was saying before because I did have someone call my name because they were not aware I was doing a video. Note to self for the future as well, and for all of you, if you ever decide to start making videos and you don't live by yourself, let everyone know that that's what you're doing. But yeah, so as I was saying, the last thing I remember saying is that, like, just because you think you're done with something doesn't mean you have to get rid of it that quickly. I do have that problem. I'm trying to unlearn that. I even get rid of messages in my phone after I think I'm done with the conversation, just so that they don't take up space. And that ends up creating problems for me in the future because then there might be something in the message that I needed. It's a whole thing. But anyways, enough about me. This basically had no reaction to vinegar. It was not scratched by a steel knife. It's very strong. So, you know, it's a high-grade metamorphic rock, so that makes sense. And there's banded alternates of white and black material, so that tells me that all those things together tell me it's probably a gneiss. I can already tell just by looking at this that it's a gneiss, but, you know, I just want to be sure by testing every other possible alternative. The dark material is probably hornblende or pyroxene. The light material is very likely to be quartz. And, you know, sodium plagioclase. Sodium and calcium plagioclases are, like, Two of the other ones that exist, aside from like the feldspar that is pink, the sodium tends to create like a lighter color, calcium creates a darker color, but they are the other like feldspar slash plagioclases that you can find in a rock. If it's not got a pink color, but it is like definitely not a mafic rock, you're probably looking at some type of plage. So yeah, here you go. This is a gneiss. That's what it's called, Gneiss. It is not spelled Nice, although there are plenty of jokes that you can make about gneiss. Yeah, I've heard them all. Geologists really are not as funny as they think they are. So, that's the first one. Now, the second one is this cool little guy that, again, looks like petrified wood and is not. You're going to find a lot of that out there, okay? There's so many rocks that you look from a distance and you're like, oh, that's petrified rock. No, it's probably not. Petrified wood, like, did I say petrified rock? Petrified wood has, like, distinct characteristics that I actually bothered to write down for you guys this time. So first of all, let's go through the little gamut after I show you the rock. This cool little guy. It's got the appearance that would make you think it's petrified wood, but as you actually study it, first of all, petrified wood doesn't tend to be laid down in like layers that create sheets. So if you're seeing sheeting in a rock, it's probably not petrified wood, and they do tend to have little knots and like, you know, circles and stuff like that in there that tell you that it's wood. So those are the characteristics you would look for. If I ever do find a sample, I'll show you guys the difference between actual petrified wood and lookalikes. This guy's not scratched by a knife. It actually scratches the knife, so it's pretty strong stuff. It looks like petrified wood, like I said, but it's not because of all the reasons I've already explained. It is lightly foliated. It's not high grade, but it is mid-grade metamorphism that you're seeing in this rock. That's why it looks the way it does. That's why it looks so shiny along the surface. Ah, there, you can actually see the shininess, like with the light bouncing off of it. And you can probably also see the layering. Those little breaks are just layers of rock, basically pressed really tight together because of, you know, pressure and heat. This is probably a phyllite or a schist, so you know what I was talking about, like those mid-grade metamorphism. This is like mid-grade, this is high-grade. You can kind of see that it's on its way to becoming that, depending on the composition of the rock. Obviously, it's not going to look exactly the same, but gneisses do exist in different colors. Don't get it twisted. There are different types of gneisses. They don't all look the same. If I have another sample of gneiss, I'll probably show you guys that. So, now, sample 3. This one is really, really cool. This one, the knife, I'm just going to read off the description and then I'll show you the rock. So it doesn't scratch a knife and the knife doesn't scratch it either, which probably means it's somewhere between that in terms of hardness, because that's usually what I'm testing when it has to do with whether it can be scratched by a knife or whether it can scratch the steel on the knife. There's also a glass scratching test that you can do if you have thick slabs of glass. I wouldn't recommend that you do that with just any glass because you're probably going to hurt yourself. But they did have little slabs that we used to test hardness on. We also used to have, you can test it with your fingernail if it's really soft. If it's a really soft rock, your fingernail can scratch it, and that tells you something about the idea of the rock. However, I wouldn't recommend trying to scratch an extremely hard rock. Don't do it vigorously anyways, because again, you could hurt yourself. So anyways, I already know exactly what this rock is, just because I remember where I got it from, and what was said about it at the time. Some of these rocks I did actually pick up on, like, field trips. I don't know if I'm going to be able to capture how cool this rock looks, because what I'm trying to show you guys is the inside of the rock. So when I originally got this rock, it was like a big slab of rock, basically, with only weathered surface visible. I cracked it open with a rock hammer, and I was able to see this cool inner, rock composition, because this is the weathered side, and this is the inside. So basically, I'll describe it for you before I can give you guys the photo, or I'll just have the photo up here of the inside. It's just really dark rock that's really shiny. It's coarse grains, so you can see all the grains. Again, there's like 2 different classifications for like how big the grains are, which also tell you something about the idea of the rock. If it's coarse grained, meaning you can see the grains and they're not all so small that it looks like one smooth flat surface and it doesn't look like there could be any grains in there at all, that would be called fine grained. The coarse grained ones are just coarse grained. The grains you can see are coarse, the grains you cannot see are fine. It's that simple. Now, with such, this is coarse grained, but it's also like mafic coarse grained. I happen to know what it is, so I'll just say it. This is diabase. So basically, it's an intrusive mafic material. I found this in the ringing rocks in PA. I won't say exactly where in PA because that might give you a clue as to where I live. But yeah, it's really nice. You'll find it, apparently, from what I've heard, you can find it in a lot of backyards in PA. It just seems to be extremely common around here. Probably because of the geologic history. There's a lot of mountains here, so a lot of cool stuff happens where mountain building occurs. And it does make sense for there to be intrusive veins. So basically what that means is that there's like a rock that already exists there, that's already solidified. And then when some kind of activity occurs, like maybe metamorphism, anything, usually metamorphism, like because something is happening geologically in the region, a new type of material can just kind of slither its way through the existing material and creating veins of, you know, a new material. And that's what it's called in, like, intrusive. It's actually, intrusive mostly means that it's inside the ground where the rock, where the magma cools. The veins are the things that cut through something and create a new material inside an older material. But yeah, so this is really cool. It's diabase. It is basically, this is the calcium plagioclase right here. Remember how I told you that there's two types of plages, sodium and calcium? So we saw sodium plage in the big gneiss. This guy has calcium plage. And that's why it's such a dark material. It's probably augite. That's what it would likely be. Probably some olivine, although you wouldn't be able to necessarily tell unless you can get close enough to see the little bits of green shining out at you. Yeah, olivine tends to be green. It's not really as common as I wish it was, honestly. Because I really like how it looks. So, now we're moving on to rock 4. So this guy's a little bit complicated, right? So I had to take some time to read my notes. Hopefully that was cut out of the video. This guy basically is a combination of like 3 different minerals. One of the minerals is a whiter color, which I found out is likely to be talc because it does not fizz with vinegar. Calcium carbonate would fizz with vinegar, but this doesn't. Even though it is soft enough to rub off on your fingers. That tells me it could also be talc. Calcium carbonate usually does not rub off on your fingers like that. And then the dark material is probably actinolite. The knife scratches it, but not deep. It's more like a powdering effect. It kind of like glides through it. It does a very surface level scratch. So that's probably why it's not any other type of rock. Because other rocks, it would scratch deeper. And then, the cool thing, remember how I told you that I have quite a few rocks that have pyrite in them? This is one of them. There's a bunch of gold little pyrite flakes in here. And so those 3 rocks are usually found together, talc, actinolite, and pyrite. That is probably a case of like low-grade metamorphism is happening. Probably contact. There's a lot of metamorphism in the general region around here in like the northeast. So it's very common to see this kind of rock here. Now I'm going to show you guys. Hopefully you guys can see it. If I keep looking over there, I'm looking at the camera to see, because I have a view from my phone to see what you guys see, and I'm trying to see if you guys can actually see the rock properly, but I don't think you're going to be able to from this angle. If you guys can see it just fine, let me know. But anyways, so the white stuff, talc, the darker material, actinolite, and the little gold flakes are pyrite. Yeah, this is the kind of stuff that people used to ruin their whole lives moving across the country just to find out that it's not gold. Imagine how sad you would be. It's really cool and neat now because it's not like my well-being depends on this being gold, but I imagine I would be very sad if I was a miner back in the day. Here you go. Rock number 5. Rock number 5, no fizz. It's scratched by the knife pretty easily. It's a deep red color. It's even scratched by my nail. So it's very soft stuff. I think that this is probably just red shale, which again is also pretty common in this general area. The red color, so the colors of shale are actually determined by different things. Black or gray tends to mean that there's like organic matter that was trapped in there, and that's why it's that color. Red shale is just a reaction with iron oxides. So here you go, a nice little red shale. There's actually a really cool place, very close to where I live. So basically there is red shale really close to where I live in the Lehigh Gap. You can kind of see one of the hills as you're walking along. Like if you are, I think it's like on the right side from where I remember it. I don't remember like exact details. It's been a while since I've been there, but I am thinking maybe I should go there for a video and show you guys exactly what I mean. So basically if you walk along like this little path alongside like these netted mountains, they put the nets and stuff like that there so that to increase slope stability, so that then there's not a terrible tragic accident with the rocks coming down, because sometimes people cut roads through areas where the slope is just not that stable, it's too steep, the rocks are not that like well ground in, etc. So anyways, if you walk along that path, you can kind of look across the river and you can see these mounds of like what looks like red rock or red dirt through the grass. That red dirt is actually red shale, Marcellus shale to be exact. So yeah, you can find some pretty cool stuff there. If you ever actually make it to the other side and somehow manage to get a sample, that'd be pretty cool. If it is private property, do not blame me if you get in trouble though. I am not telling you to do that. I am just saying it would be cool if you could get a sample. I'm not sure if you're even going to be allowed to though. So yeah, this is just pyrite bearing calcite. Basically it's got pyrite in it, but the main host rock is calcite. I actually do have a video of me testing whether it's calcite or not. So you know how I told you that I couldn't get the hydrochloric acid that I wanted, and I'm honestly scared to try to buy a lower concentration again in case, you know, the government thinks I'm trying to kill someone. So I'm just not even going to bother with that anymore, and I'm going to use white vinegar because it works just fine. You can just drop your rock in the white vinegar because that's what you have to do. With white vinegar, unless you manage to get it into a drop bottle and you're patient enough to look really closely at the rock as you drop vinegar on it, because it's not going to have that strong of a reaction like it would with hydrochloric acid. It's better to just get a little shallow like bowl, way more shallow than the one I used in the video. It's probably going to be somewhere here. Alright everyone, this is the calcium carbonate test. You just drop a rock in white vinegar since it's not strong enough that you can just drop it on and it'll fizz immediately like with hydrochloric acid. This is how we have to improvise. Let's see if any fizzing is happening. Oh. You see those bubbles? That tells you that you have calcium in your rock. Because that's just basically the vinegar eating away at the organic material in the rock. Super cool, right? Anyways, so in that video, you basically just drop the rock into, like, you basically just drop it into the vinegar and you watch to see if bubbles come up or if you see bubbles on the surface of the rock. Sometimes you have to look pretty close because it might not have a strong reaction, but if it has any calcite or like any type of like carbonate or something like that in there, it will have even a slight reaction, and that's how you know that that's in the rock, that you have calcite in there. So this reacted pretty strongly, I'll say. So it's definitely got calcite. I would venture to say that the most of the rock is calcite and that there's just pyrite in here. Again, it rubs off on your fingers. Sometimes that does happen with calcite. I know I said that that doesn't happen with it often, but it can happen. It depends, I guess. So yeah. Really cool rock. Let's see if you guys can even see the little gold flakes. Again, this may be up to the picture to save. So yeah, that got weird. It got a little bit frozen on my phone and I couldn't see the preview anymore, so I just restarted the video from my end. Anyways, you guys don't have to worry about that. So another sample of calcite. This is a really pretty one. Calcite doesn't always look the same. I'm just gonna tell you that. First of all, when I refer to calcite, I'm saying it kind of wrong. You know what I mean? Calcite is the igneous like rock, or rather the mineral. It's not an igneous rock. That was wrong too. It's the mineral. Like, it's the pure mineral form. Carbonate, or any type of, like, you know, calcium bearing rock, is more sedimentary. So that's more of what you're gonna find out there. But anyways, this has calcium in it, for the people who are very specific about being correct. This has got to be the prettiest rock I have found, and I'm sorry, it was a lot prettier before I ruined this side. So when I tested it for calcium, because I honestly thought, I don't know why, I saw the pink color and I kind of just assumed that that meant that it had like potassium feldspar when I first got this rock. And then I was told, actually, that's a calcium bearing rock. There's really no potassium feldspar in there. Yeah, I can see that they were correct. I tested this in the vinegar and it pretty much burned away the pretty color wherever it touched. And then it just became this like kind of ugly brown color underneath. So basically that's just like iron oxide residues after the reaction. Like after it's burned away all the pretty stuff on the surface, yeah, that's what it leaves behind. So if you really care about how pretty your rock samples look, maybe don't drop the whole thing in like a container of vinegar, just a small part to see the reaction, because yeah, I'm not going to be able to recover that side. I'm just going to have to put it so that the pretty side faces me when I put it back on my shelf. But it is what it is, you know, all for the sake of science. Now, this also has calcium in it, but this is actually a pretty cool little sample because it allows me to tell you about something pretty interesting. So, I'm going to try to explain this as simply as I can. Whenever, whenever calcite, or, you know, how do I actually explain this? I'm going to think. So, calcium carbonate is actually, like, the scientific name because it has to do with the atoms, the elements that make up the carbonates, right? Like, specifically the calcite carbonates. So basically I can't remember the exact number, CO3, I think. I'll go ahead and look up the specific one, or I'll have my editor look it up and then just put the actual element name up here. Like it'll just be a little, you know, a little nice little screen grab. There's such a thing called a polymorph, which are basically just minerals that have the same chemical formula, but that's the word I was looking for, formula. They have the same chemical formula, but they actually have a different way of, like, arranging the atoms. They have a different structure. So, this is an example of something really cool that happens in nature with polymorphs. So, there's such a thing called aragonite. That is a rock that slowly that's the mineral that starts to turn into calcite as time goes on. This is aragonite turning into calcite. The aragonite is the orange stuff. The calcite is the white stuff. So the calcite part, like the white part, actually does fizz. The orange part does not. It fizzes like a very small amount. It doesn't do much reaction like the calcite does. So basically, this is just, yeah, aragonite turning into calcite over time. It's mostly because aragonite is sometimes easier to work with for the organisms that are building whatever they're building than calcium. It's just over time it turns into calcium. Yeah, really cool stuff. There we go. Let me tell you, I'm really struggling with filming today. I don't know what's going on. I'm going to try to get through the rest of this. I think my brain is just kind of imploding from how busy I've been these past few days. Anyways, so now we are up on the finish line. We only have 2 rocks left, thank God. I don't know what's happening. So, this is pretty easy. This is a granodiorite. It's pretty simple. I actually scratched myself trying to test the hardness of this rock. You really need to be careful with those steel knives. Fortunately, it wasn't that serious of damage. It was just a tiny little cut because it only slipped a little bit against my skin. But still, when you are scratching the rock, do not do it like this where it could get your fingers. Get it away from you. That way you don't hurt yourself. And if you really need to put pressure on it, put the rock down and be careful. Just press it down on the rock. Do not press it down anywhere where your fingers could end up getting cut. Okay? This is from me to you. Because I cut myself so you didn't have to. So yeah, this is a granodiorite. What that basically means is that it is mostly an intermediate, yeah, it looks like a pretty intermediate igneous rock. There's dark material, there's light material, not quite a granite, not quite a diorite. It's most likely a granodiorite. And yeah, it's pretty cool stuff. It's got that salt and pepper look that tends to point you to a dioritic type rock. And now this guy. This guy I thought was going to be a lot harder to like identify, but for some reason it ended up being easy once I actually, when I first started to film the rock IDs, I was so like wary of this one because it has such an odd appearance that I couldn't figure out what it could be. But now I've gotten to a point where I've done enough rock ID that I feel more confident trying to ID it. So, first of all, let me show you. Yeah, there's just dark patches kind of intertwined with the light patches. I think I would venture to say that the majority of the rock is the lighter material, but that would probably be wrong, honestly, because it looks as if it's one rock mineral type. You know what I mean? Even though it looks different, stay with me, I'll explain it. So the white part doesn't scratch. So, anyway, scratch what I just said, because it is not one type of rock, actually, because the white stuff doesn't scratch, but the black stuff does, and the black stuff also fizzes. So it's two rock types there. The white rock is probably quartz, because that's the usual culprit for, really strong rock that doesn't scratch with a knife, probably quartz. And the dark stuff bubbles with exposure to vinegar, so it's just a carbonate. The black color is probably due to oxides or like organic inclusions. You know how I told you that shale can have different colors? So can carbonate. Carbonate doesn't always look the same. Sometimes it's light, sometimes it's dark. As long as it fizzes with acid, it's probably a carbonate. The dark color is usually because of organic inclusions. Carbonate doesn't tend to be black all by itself. Thank you for dropping by to look through all my rocks. This was probably a lot easier for you guys to sit through than for me to make. If my editor did a good job, I'll go ahead and put all the photos up as I go along. And I'll even put a group photo at the end because I think that was a good thing that I may have missed in the last two videos. So you guys can see kind of the general size comparison of all the rocks. Because I have quite a bit of variance in rock size. As you guys will see, I actually will do more rocks later. The last rocks I'll be doing are the very small minerals that I have specifically in a glass case. That way they don't get lost, because it's very easy for the little ones to get lost or disappear when you're cleaning. They could just kind of go flying away, and then you don't never see them again, essentially, until you're probably moving furniture. So, thank you again for sitting through this, and, just look around. You never know what you could find, and stay curious.